As always with a proof, we start with the given information. So, segment AE and DB bisect each other. And that was given. Because I see that word bisect, I'm going to use the definition of bisect in my next statement. And since they bisect each other, AE bisected DB, but DB also bisected AE, it does mean that AC and CE would be congruent. But it also means that DC and CB would be congruent. That kind of used up what they gave me. Now I'm going to come over and look in the picture. I see that I have angle 3 and angle 4 that are congruent because they're vertical angles, and all vertical angles are congruent. Now if I look at my triangle, I see I have a side, an angle, and a side, an angle, and a side. So I can state that triangle ACD, the order of the first triangle doesn't matter, but it does determine the order of the second one, would be the same as ECB. And this would be by side, angle, side. Now I should be able to see that AD, the outside 2, would be the same as EB, the outside 2, because they are corresponding parts of congruent triangles, and corresponding parts of congruent triangles are congruent. Number 2. Angle 1 is congruent to angle 6. I'm going to make sure I mark that given information in my picture. Segment EF is parallel to segment GH. I'm going to make sure that that is marked as well, and that it is given. EF is parallel to GH. Now, because I saw this parallel lines, I'm looking for a set of alternate interior, alternate exterior corresponding or same side interior. These are the two lines that are parallel. And just to help everybody see it, I'm going to kind of highlight it. This line and this line makes this the transversal, which means that angle 4 and angle 3 are congruent. And they are alternate interior angles. And alternate interior angles would be congruent so long as the lines are parallel. The other piece is GF is congruent to GF. By the reflexive property. Now I can see I have an angle, and a side, so I can state that the two triangles are congruent. Triangle EFG would be congruent to triangle HGF. Again, the order of the first one doesn't matter, it just determines the order of the second one by angle, angle, side. And then last but not least, what they asked me to prove, that segment EF would be congruent to segment HG. And again, if I look at my congruence statement, I can see that EF and HG were corresponding parts, so I can use CP/CTC. Number 3, segment AD is congruent to segment CD. They've given me information. I'm going to mark that in my picture. Segment AC is perpendicular to segment BD, and I'm going to mark that in my picture. If two things are perpendicular, they form right angles. So I'm going to make that statement that angle 2 and angle 3 are right angles. And I can make that statement because perpendicular lines form right angles. Well, if 2 and 3 are right angles, then triangle ABD and triangle CBD are in fact right triangles. That's simply by the definition of a right triangle. I can see that BD is congruent to itself. It's shared in both of those. Since segment BD is congruent to segment BD, that's the reflexive property. If I look at my picture then, I know that triangle ABD is congruent to triangle CBD by hypotenuse. This is the hypotenuse. This is also hypotenuse across from the right angle. And this side would be the leg. So I can prove these two congruent by hypotenuse leg. Remember, this is not the only method that I could have used for this triangle. There are other things that I could have done. This is just one method. Number 4, because this is an equilateral triangle, each one of these angles has to be 60 degrees. So I do know that 5x plus 3 had to be equal to 60, and 7y minus 4 also has to be equal to 60. If I subtract 3 from both sides, I have 5x is equal to 57, and I'm going to divide both sides by 5. X is equal to 57 over 5. Now, I personally left mine as an improper fraction. If you did change it, this comes up to 11.4. Why? I'm going to add 4 to both sides. I have 7y is equal to 64, and divide both sides by 7. Again, I left mine as an improper fraction, 64 over 7. If you put this as a decimal, this would be approximately equal to, because it does repeat, 9.14. In problem number 5, I looked at this triangle and noticed that it was isosceles, so I know that whatever these two angles are, they are going to be the same because they're across from the congruent sides. Out of the 180 degrees, I've used up 29 of them. So there is 151 degrees left. And since I have to divide it between two angles equally, I'm going to simply divide that by 2. So each angle that's left in here has to be 75.5. So x is 75.5. And the other equation is going to be written 3y plus 1.5 equals 75.5. Subtracting 1.5 from both sides, I now have 3y is equal to 74, and I'm going to divide both sides by 3. And again, I left mine as y equals 74 over 3. I left it as an improper fraction. This is one that is going to repeat, so I'm going to put approximately equal to when I change it to a decimal. This would be 24.6 repeating, or 24.67, because I would have to round that up. Number 6. The trick with number 6 is making sure that you're looking at individual pieces. So I'm going to look at the triangle that's here on the left-hand side first, because it's where they give me a numeric value. I noticed that it was isosceles, which means the angles across from the two congruent sides are congruent. So x is 68. In this green highlighted triangle then, I've used 68 and 68. So I've used a total of 136 degrees. Out of the 180, they're in a triangle. I take 180, I subtract the 136 from it, and I find out the remaining angle is 44 degrees. I use the concept of a linear pair then to find y. Y is in this other triangle, and I need a measurement over here to get started in it. So I took 180 minus the 44. I'm back at 136 degrees, just like these two were. So y is 136. If I take 180 and I subtract the 136, there is 44 degrees left. I noticed that this was isosceles, so these two angles are going to share that 44 equally. So I took 44 and divided it by 2. So z is 22. I'm going to come over, do the same thing for number 7. This time they gave me information on the right side first. So I'm going to look at this triangle first. There's 180 degrees in a triangle. I've used up 110 of them. There is 70 left. Because this is isosceles, the two base angles of this isosceles triangle would be congruent. So I'm going to take that 70 and divide it by 2. So y is 35. Again, using the concept of a linear pair, these two angles have to add up to 180 degrees. So when I subtract that 110 from 180, the angle over on this side is 70. And now I can look at the triangle that's over here on the right-hand side. In this triangle, I again notice that it's isosceles. So I know that the two base angles of an isosceles triangle are going to be the same. Whatever x is equal to, z is equal to the same thing. Out of 180 degrees, I've only used 70 of it so far. There's 110 left, but I have to divide that equally between the two angles. So x and z are both equal to 55. Number 8 says ABC is an equilateral triangle. If you're talking about an equilateral triangle, draw an equilateral triangle, mark all the sides as being equal, and put in the value of 60 degrees for each of the angles, because they would all be equal as well. I'm going to go ahead and label my triangle ABC. It doesn't matter which side gets labeled as what with it being equilateral. It says AB is 2x plus 10. It says BC is 5x minus 11. It says AC is 3x plus 3. Because it's equilateral, all I have to do is pick one pair of sides. Does not matter which pair I pick. I'm going to pick 3x plus 3, and I'm going to pick 2x plus 10. Because it's equilateral, I do know that these sides are equal to each other, so I'm going to set them equal. I'm going to go ahead and subtract the 2x from both sides. I now have x plus 3 is equal to 10, and I'm going to go ahead and subtract 3. X is equal to 7. They asked me to find the value of x, but they also asked me to find the length of each side, and I'm going to plug that 7 back into one of my sides. 2 times 7 plus 10. 2 times 7 is 14, plus the 10 is 24. So the side length is 24, and the segment side length is 7. Okay, when you're working a problem like number 9, you're going to work the picture before you actually answer the question. A equals B equals C equals D, E, F, G, and H. I'm going to come over and work whatever I can find in the picture first. The first thing I notice is this linear pair. So I take 180 and I subtract 106 from it, and I find out the remaining angle was 74. If this is 106 on this side, over here is vertical. This is also 106. If H is 74, then B is also 74. I look at the triangle that's on the bottom. I've used 74 degrees and 62 degrees. So I've used a total of 136 out of 180, which means the angle that's left is 44 degrees. So G is 44. And because this is marked as being congruent, C is also 44. I notice I have 74 and 44, so if two angles of one triangle are congruent to two angles of another triangle, then the third angle is also congruent. Third angle theorem says this has to be 62. If I come down to this corner then, I would notice that this was 90 degrees. I've used up 62 of them, so this would be 28. And there's two different ways that I could find D. I noticed this 90-degree angle, and I subtracted 44 from it, which would give me 46 degrees. I should be able to see if I add 46, 106, and 28 together, I do get 180. And so A is 62, B was 74, C is 44, D is 46, E is 106, F is 28, G is 44, and H is 74 degrees. Number 10, one base angle of an isosceles triangle. If it's isosceles, I'm going to draw an isosceles triangle. These two sides are congruent. It said one of the base angles was 2x plus 4. It says the vertex angle was 6x plus 2. Remember that the base angles of an isosceles triangle are congruent. So if one was 2x plus 4, the other is also 2x plus 4. Inside of a triangle, they always add up to 180 degrees. So I'm going to take the 2x plus 4 plus 2x plus 4 plus the 6x plus 2 and set it equal to 180 degrees. Combining my like terms, I have 2x and 2x, which is 4x, and 6 more x, which is 10x. I have 4 and 4, which is 8, and 2 more, which is 10, is equal to 180. Subtracting 10 from both sides, I now have 10x is equal to 170, and dividing both sides by 10, I get x is equal to 17. Remember, this is only part of my problem. They also asked me for the measure of the base angles. So the base angles were 2x plus 4. I'm going to replace that x with the 17 that I just found. 2 times 17 is 34, plus the 4 makes each of the base angles 38 degrees. There are my two solutions. 3 sides of an equilateral triangle. If it's an equilateral triangle, I'm going to mark all the sides as being the same, and I'm going to write in each angle as being 60 degrees. It says one of the sides is 3x plus 17. The other side is 8x minus 3. And one of the sides is 5y minus 1. I can pick any two sides. I'm going to pick these two because they have the same variable. And I'm going to set those two equal. 3x plus 17 is equal to 8x minus 3. Subtracting 3x from both sides, I have 17 equals 5x minus 3. Adding 3 to both sides, I have 20 is equal to 5x. Dividing both sides by 5, x is equal to 4. There's one of my answers. I still need to find the value of y. I also need to find the value of each side. Well, y is going to be difficult to find until I find the value of a side. So I'm going to plug that 4 back in. 8 times 4 minus 3. 8 times 4 is 32. 32 minus 3 is 29. So I know that this side is equal to 29. 5y minus 1 equals 29. Add 1 to both sides. I now have 5y is equal to 30, which means y is equal to 6. So x is 4, y is 6, and each of my sides is 29. Number 12, they told me that ABC is equilateral. It may not look it, but all of these angles are in fact congruent. This side, and this complete side are in fact congruent. It said AD was 3x minus 2. It said DC was 3x minus 2. It said BC was 4x plus 10. And remember, since each of these angles were congruent, each of these angles was 60 degrees. And it said angle A was 4x plus 8y. Since AC and BC are congruent, I'm going to add these two pieces together using segment addition postulate to get AC, 6x minus 4. 6x minus 4, therefore, has got to be equal to 4x plus 10. Subtract 4x from both sides. I now have 2x minus 4 equals 10. Adding 4 to both sides, 2x is equal to 14, and dividing by 2, x is equal to 7. There's one of my variables. Here's the other equation. 60 equals 4x plus 8y. I can take the x that I've just found and I can plug it in. 60 equals 4 times 7 plus 8y. 4 times 7, 28. Subtract the 28 from both sides. I get 36 is equal to 8y, and divide both sides by 8. Y is equal to 4. This would have been 32. Bad math. ID 10T mistake. 32 divided by 8 is 4. So my values for x and y, x is 7, y is 4. Number 13 through 16, they're asking you to state what's missing to use this theorem to prove that the triangles are congruent. It says BD bisects angle ABC. If it bisects angle ABC, ABD and DBC would be congruent. I also know that BD is congruent to itself. I can see I have an angle and a side. I need to make sure that I have the non-included side, so I would need that angle A is congruent to angle C. And it's more than just marking it in the picture, it's actually making sure that we write that missing piece out to the side. In 15, they said angle A was congruent to angle C. They said angle CBD was congruent to angle ABD. And they want me to use angle side. BD is congruent to itself. There is nothing missing in this problem to use angle side. It's really all given to me. Number 14, BD is a perpendicular bisector. If it's a perpendicular bisector, not only is it going to make the right angles, it's going to cut AC completely in half or into two equal pieces. They want me to use angle side angle. There's a side, so I could state that angle A is congruent to angle C. That would be one method. I do know that BD is congruent to itself, so I could also have stated angle ABD is congruent to angle CBD. Either one of these would certainly work. I'm sure they were looking for A and C, not using that reflexive property. BD is perpendicular to AC, so I know that it makes right angles. This time they did not tell me that it bisected it. I know that BD is congruent to itself, and they want me to use side angle side, so my angle needs to be included. So I'd need to know that AD is congruent to segment DC. Okay, number 17. Since this is isosceles, if this side length is 10, x is also 10. Out of 180 degrees, I've used up 30. There's 150 left, and the two base angles have to be congruent, so I'm going to divide this by 2. So y would be 75. If I look at this one and I treat it as a triangle as a whole to start with, it is an isosceles triangle, and I know that 50 degrees was used up here. And I know that these two base angles then would have to be congruent. 180 minus the 50 leaves 130 degrees, and I'm going to divide that by 2. So each of these angles has to be 65. X then is 65, and this angle over here is 65. And now I'm just going to look at a different triangle. I'm going to look at where y is at. I've used 25 and 65 so far out of the triangle. So I've used up 90 degrees out of the 180. So I know that y has to be equal to 90. So x is 65 and y is 90. If this is 100 degrees on the outside, x and this 100 make a linear pair. So this is 80 degrees in here. X must be 80. If it's 80 where x is, it's 80 over on this side. There's 180 degrees in a triangle. I've used up 80 of them. So there's a remaining 100 degrees. This is isosceles, so the two base angles have to be congruent. So it's going to share that 100 degrees equally. So each one of these angles must have been 50. This is an equilateral triangle. If the side is 24, all the sides are 24, so x is 24 degrees. And all of the angles, since it is equilateral, are 60, so y is equal to 60. When you're doing these, you want to think about maybe having two different colored highlighters so that you can see where they actually overlap. And it is best if you separate them out. So there's ABC, and I'm just going to redraw it instead of dragging it like a lot of times I do in class so that you can see here is the triangle that I just traced out. Here's A, it had 2 marks on it. Here's where B is, it's this whole angle, and here's C. Then I'm going to trace out the other triangle that's here. And I'm going to redraw it as well. Here's B, here's C, here's D. I can see that these two were marked, it's marked with 2 lines. This one was marked with 1. If I look at my picture, I should be able to see what they had in common completely. BC was congruent to itself, BC. And I can see I now have angle, angle, side. So this is how I would prove these two congruent. Likewise, I'm going to come over to this next picture, and I see that they have this angle, so they must be talking about this triangle, and I'm going to separate it out. I try to keep the orientation kind of the same. It kind of helps visualize what's there. This is H, this is K, this is L, and I know that I have this marked, and I know that I have this little piece, LK, marked as being congruent. The other triangle then that I'm looking at, I've now highlighted in green. And so it's going to look like this. This is M, J, L. And I know that ML was marked with a mark, and that angle J was marked with a mark. I don't notice any side completely overlapping, but this time I do know that angle L is in both of these triangles. And so I'm going to put it in my picture where they're separated out. And now I can see I have an angle, and I have a side. Again, just taking a highlighter and tracing over the triangle. I'm going to separate out this triangle. I know that this is 90 degrees. I know that this is marked as being congruent. This is N. This is O. This is R. And highlighting the other triangle in a different color. And drawing it out. I can see that this is N, it's marked with a mark in it. This is O, it's the right angle, and this is P. And I should notice where they overlap. There's green and pink in both of these right here, so NO is congruent to NO. And I can see I have an angle, a side, and an angle. In the next one, when I go to highlight the two triangles and separate them out, and I know that I want to highlight this triangle because they're talking about this angle. And I'm just going to go ahead and separate it out. This is T, this is S, this is V. And I know that I have TS, and I know that I have this angle S in this triangle. When I go to do the other triangle, which would be here, and I separate it out, I have S, I have U, I have W. SW was marked, and where the S is was marked. I see I have an angle and a side. I have an angle and a side. Nothing was completely overlapping. Now I'm going to look at the whole triangle. I'm going to look at it as one great big whole thing. And if I look at it as a whole, I should be able to see that these two sides were congruent. So the whole triangle is isosceles, which means where this T is congruent to where W is. And I'm going to mark that in my picture down here. When I do that, I can see I have an angle, a side, and an angle. Make sure that you study. Know that there are 2 proofs that'll be on the test, but they've given you all the statements and you just need to supply the reasons.